So this is the last part. Okay, so in previous parts, what we have seen, if there is conflicts, either you can use timestamp, which is not very reliable, or you can use version vector, which is nice, or you can use operational transform. By that, we have also seen like how Google Docs actually works. Okay. Now last is CRDT. Okay. So this is basically state-based CRDT. Okay. So in state-based CRDT, so in operational transform or operational CRDT, the problem was that we only send the operation which happened, like add or delete, like that. And if there is a replication delay or the centralized server goes down, there can be problem. Okay, so they cannot connect peer to peer. But here, so this is basically what was happening. If we are sending like uh, increment L by 2 and here we are sending increment L by 3, there will be a centralized server who will do this. If this goes down, we are screwed. So in state-based CRDT, what we do is that we send the whole state, okay, and then when we send the whole state, we use merge function. Okay, so the merge function will be run over here. So in this is 1 dB, this is the second dB. Okay, so the merge function will be run where there will be 2 comma 0 plus 0 comma 3. Okay, and similarly here the merge will be running merge function. Okay, here also 2 comma 0 plus 0 comma 3, and when the result comes out, it becomes 5 for both of them. Okay, or like 2 comma 3, and here also 2 comma 3. But what will be the like properties of the merge function? The properties of the merge function will be, the merge function should be commutative. Okay, commutative, which means f of a comma b equals to f of b comma a. The merge function should be associative. Okay, associative, which means f of a comma f of b comma c should be equals to f of a comma b comma f of c. Okay, and merge function should be idempotent. Okay, it should be idempotent. Okay, so yeah, this three properties should be there in the merge function. If any one of them is not matching when you do the operation, then sadly you have to go with manual intervention. Then you have to manually make the conflicts resolve. So who use this state-based CRDT or like actual CRDT? So it is used by Redis. It is used by Autodesk. Okay, let me like give you a top view what happens in Autodesk. I'm not saying like this is what actually happens. For understanding the whole conflict, resolve conflict thing, you basically have to do PhDs. Obviously I'm not doing PhD over here, so let me just give you a taste what happens. And cool. So in auto merge, what happens, the data structure is in form of JSON. Okay, so I'm basically taking the example of Martin, who has written the one O'Reilly book. Okay, and he's like very one of the researcher. You can actually find his one of his lectures in YouTube also. I will link his video in the description. But yeah, basically this is in a form of JSON. Okay, and either it can be list or a map. Okay, and let me give you like in the list we will have the title, which is like buy milk or like water plants or whatever, and the state of the state, like state is done or not done. Okay, so this whole thing is a state, okay, which will be sent to each other. Okay, So this is one state, this is one state. Okay. And basically whenever you make any changes inside the states, okay, these are logged in a, it's like a write ahead log, you can say it, basically you can say operation logs, okay, which are stored so that you can actually time travel. Like if something goes like horribly wrong, you can go behind and solve the conflicts yourself. And for like how does it simplifies the conflict, like how does it merge the two conflicts, let me just give you example. So this is like happy path scenario. So let's say there are two people using one app, which is like to do app, okay. And the first, initially there are like water plant whose status, which is done or not, is false, okay. So both of them have the same status, okay. Now what happened, uh, the first guy actually added a new to-do list, added a new item in the to-do list, which is buy milk, and the status is not yet done, which is false. But the second person actually watered the plants and he marked it as done status from false to true. Okay. When they sync up, when they sync up, what happens that they have like water tank. So they send the whole state to each other, right? So what happens that water plant equals to true and buy milk equals to false, and over here water plant equals to true, buy milk equals to false. This is what happens. So they send the whole state, basically the whole JSON to each other. But this is like not very happy path. So again, this is the to-do list where both of them were having initially buy milk, which is equals to false, and buy milk, which is equals to false. Then the next state, okay, this guy added that buy soya for proteins, and this guy also added buy almonds for proteins. Okay. Now in this step, basically they are syncing. So obviously there will be a conflict. So what happens that buy milk equals to false, it remains same. Okay. But the next one, which is buy soya equals to false, it got added in both of them, but there is a conflict which will be mentioned. Okay. And here it will be buy almond equals to false is in conflict. So now user have to like go himself and make the changes. It's, you can take the example of like GitHub. So in GitHub also, like this is the main branch. This is the main branch. You are making some changes. Okay. You made some changes and some other guy also made some changes. So when he tries to push, he have to resolve the conflicts, right? So similar way actually. Obviously GitHub doesn't use CRDT. It use more advanced feature like, so CRDT also actually have lots of algorithm. It sometimes use sets, sometimes use vectors, sometimes use maps, sometimes use trees, and there are like n number of algorithms which are there for this, that you have to like dig through companies' secret documents, which obviously I don't have. Uh, so yeah, this is all about CRDT. Thank you.